The adoption of hybrid cloud strategies has become a common response among AI startups seeking operational resilience, regulatory flexibility, and latency optimization. However, the assumption that distributing workloads across multiple cloud providers automatically creates structural independence reflects a misunderstanding of where real leverage resides within the AI stack. Redundancy protects uptime, but independence is determined by control over the layers that define compute access, pricing authority, and strategic scalability. And these layers often remain externally governed even in multi-cloud environments. Hybrid cloud architecture is designed to mitigate localized outages, distribute data geographically, comply with jurisdictional regulations, and provide limited negotiation leverage between infrastructure vendors. Yet these advantages operate primarily at the operational level rather than at the structural level. Because the core intelligence layer of most AI products, particularly those dependent on external model APIs, remains tightly coupled to upstream providers whose pricing, allocation policies, and contractual terms define the economic boundaries within which downstream companies must operate. In other words, distributing servers does not equate to distributing power. To understand where the illusion breaks, it is necessary to examine the layered architecture of an AI-dependent business model, beginning with the visible interface layer, where users interact with applications, moving through the application logic layer, where workflows are orchestrated, descending into the model access layer, where intelligence is rendered through APIs, and finally reaching the compute layer, where large-scale hardware clusters execute inference and training processes. While startups may exercise meaningful control over interface design and application orchestration, the model access and compute layers are frequently centralized among a small number of hyperscale providers, meaning that strategic ceilings are defined externally, even when operational redundancy appears diversified. Consider the structural implications of a sudden pricing adjustment at the model access layer. If a primary inference provider modifies token pricing, adjusts rate limits, introduces new tier structures, or alters contractual terms, the downstream startup must either absorb margin compression, pass costs to customers, or re-architect its entire system to accommodate alternative providers. A transition that may involve latency shifts, performance variability, retraining costs, and engineering overhead. Hybrid cloud does not eliminate this exposure because the dependency is not located at the server layer but at the intelligence layer itself, where control remains concentrated. Furthermore, compute concentration amplifies this asymmetry. Because large-scale AI capabilities require access to specialized semiconductor hardware, sustained energy supply, and capital-intensive data center infrastructure that only a limited number of organizations can finance and coordinate at scale. As a result, while hybrid cloud can distribute workloads across regions or vendors, it does not decentralize the upstream control of advanced compute resources, and therefore does not fundamentally alter the structural position of companies that rely on rented intelligence to fuel growth. True structural independence in the context of AI does not arise from architectural redundancy alone, but from model optionality, diversified compute relationships, pricing resilience, capital durability, and governance alignment that collectively reduce single-point dependency risk. Without these elements, hybrid cloud becomes a cosmetic sophistication rather than a leverage-shifting strategy. Creating the appearance of resilience while leaving the foundational power dynamics intact, operational diversity may create flexibility, but structural sovereignty requires control over the layers that define possibility itself. Innovation at the interface layer may drive adoption, user growth, and market visibility. Yet control at the infrastructure and intelligence layers determines who ultimately retains strategic leverage under conditions of volatility, pricing shifts, regulatory pressure, or capital tightening. Therefore, the critical question for any AI-dependent enterprise is not how many cloud providers it uses, but how deeply its core intelligence and compute pathways remain exposed to upstream concentration. Redundancy without sovereignty remains dependency, and dependency defines the true boundaries of growth.